Hey guys, how's it going? We continue with our questions. So maths questions. Okay, so question 12, it says base year records the color of 100 cars passing the school gate. Results are recorded in the table. So this is the table here. We have the color of car here, it's recorded, and then also the corresponding frequency. Okay, so you're asked to use base year's results to estimate the probability that the next car seen is a blue car. Okay, so you're asked to estimate the probability of which you're either, this one is called the sample. Okay, so this is the sample. The sample size, it's 100 cars here, and then for black cars, the frequency is 43 out of the 100 cars. So you can say the probability of getting a black car would be 43%. Okay, so here you're asked to estimate for the blue car. So the blue car, the number of cars, it's only 9. Okay, 9 out of what? Out of 100. Okay, so probability of, you can say blue car, it's still fine inside here, it's equal to 9 out of 100. Okay, so this one's usually they'll give you 1 mark for it. 1 mark, it means the answer is either very simple or the answer is just a dead giveaway. Okay, so sometimes the number of marks can actually tell you how much effort you're supposed to put into your question. The next part, it says in the next hour 500 cars pass the school gate. Okay, so now we're changing the sample here. Use base year's results to estimate the number of these cars that are red. Okay, so we are using still our sample size here. We need to find the probability of getting a red car here from the sample. Okay, so from the sample, red car would be 12 out of 100. Okay, just double check here if 9 over 100 is in its lowest terms. Okay, because it's important. 9 over 100 is in its lowest terms. Here it's 12 over 100. 12 over 100, we can put it in its lowest terms if you want. Okay, so it would be 4 into 12, you'd get 3, and then 4 into 100, then you get 25. So it's simply 3 over 25 here. So the number of cars, so you can say number of cars, it's equal to, now you say the probability. Okay, so the probability, you can say 500, which is the number of cars here. So number of cars desired, so you can say number of cars red here. Okay, 500 times probability of getting a red car. Okay, so here we're using more or less a simple proportion. Okay, so we know that for every 3 cars, or for every 25 cars, 3 will be red. So we want to know what should be the result for 500 cars. Okay, so 500 cars would be 3 over 25 here multiplied by 500. Okay, so this is another thing that you should know about math. If this one is not the final answer, you can actually just leave it as it is right now. Why? Because sometimes it's easier to actually work with this than to work with whatever you have reduced it in. You have reduced it to. So 3 over 25, it's actually harder to work with. You could just work with what you have here. So what you have is 12 over 100. Okay, so you can simply cancel here. Then you get 5 by 12. 5 by 12, it's equal to what? It's equal to 60. Okay, so you can say 60 cars here. So that's it. All we had to do was to use a simple proportion. You know that the probability of getting a red car, it's simply 12% or 12 over 100. Okay, so you want to know what should be the number of cars for 500. So you just use a simple proportion and then you're done. Okay, so let's move on to the next part. The next part says Colin records the color of the next 100 cars passing the school gate. So these results are shown in the table below. Okay, so you can just check this one. It's also a sample of 100 cars. Okay, so 100, it's a very easy number to use, just because you can use the concept of percentage, and also you can just know the sample size. It'd be easier to handle. Okay, so here you're asked to use base year's results. Okay, so base year's results from previous, and then Colin's results from here, to estimate the number of red cars that would have been seen when 500 cars passed the school gate. Okay, so you're supposed to use both the results from previous, and then the results from previous, there these. Okay, these are the results from previous. So here our sample would be 200, since we are considering the base years, and then also for call-ins. Okay, so the results for base year, and then also for call-in. So you're dealing with a sample of 200 cars. Okay, so you want to estimate for red cars. So red cars would be probability of red car would be equal to, okay, so calculate the number. You're asked to find the number of red cars. Okay, so probability of red car from the combination will be equal to it'd be 18 plus 12. Okay, so divided by the whole number, which is 200 for a case. Okay, so 18 plus 12, you get 30 over 200. Again, don't reduce anything. Okay, you can just leave it like this, it's still fine, because this is not your ultimate answer. You actually want a specific number of red cars. Okay, so therefore number of red cars, yeah, it's equal to, so probability, so you can say 500 first. So 500 is the sample size, and then the simple proportion would be the probability for our case. So it's equal to probability of red car here, just like this. Okay, so now it would be 500 multiplied by the probability of getting a red car. It's 30 over 200. Okay, so now you just cancel, and here you can also cancel, and then cancel here, you'd still get the same answer. Okay, so what I'm going to do is I'm going to say 5 by 30. 5 by 30, you get 150. Then 150 divided by 2, what do you get? You get 75. Okay, so you can write 75 cars just to clarify. But then essentially this is it. Okay, so there's actually an interesting question that comes afterwards. So we combined these two samples. The sample size, the new sample size would be actually 200. Okay, so the number of red cars would be 18 plus 12, which would be 30. 30 divided by 200, which is the whole sample size. We can use that simple proportion to get the corresponding number for 500 cars. So it would be just the probability that you have multiplied by the new sample. Okay, this new sample is 500, so you get 75 cars there. So 75 would be the number of red cars. The question says which of the estimates in part B or part C is likely to be the best. Okay, so which of the estimates is likely to be the best? So you have to explain which one is likely to be the best here. So the best or the better. Okay, so the best estimate would be in part C. Okay, so this one you get 1 mark for this. Okay, so you have to explain the reason. Okay, so this is the reason. So generally when you increase the sample, you increase also the accuracy in the result. Okay, so you're dealing with two situations where at one point you had 100, a sample of 100, and then in the second case you had a sample of 200. So if you have a sample of 200, your probability will be actually converging to the most accurate answer. Okay, so if you have a sample of 1,000 people, let's say you're testing them for COVID, you have a sample of 1,000 people, the answer that the statistics that you get from there will be more meaningful than if somebody had a sample of 100. Okay, just because as you increase the sample, you would actually converge to the accurate answer. Okay, one way to think of it is if you want to get the most accurate answer, you actually have to have an infinite number of samples. Okay, so that's one way to look at it. So this is how you'd work out the probability question. Thanks so much for watching. I'll catch you in the next one. Yuba out.